Hello, everybody. It is Sanjay and Samuel here from RESK8. Today, we're going to give you an overview on the basics of ESK8 because we believe that it's essential to riders to learn how their boards work, why they work, and just give you a basic overview. We love ESK8, we love personal electrical vehicles, and we just want to make sure that people are more informed about how they work.
Yeah, so my name is Sam Wiewel. I'm a mechanical engineer. I just recently graduated from university, and I've been involved with Sanjay here for a few months as we're kind of culminating this new company and providing a product to everyone. And today, like you said, we're just going to go over some of the basics, some of the stuff that matters to people who are just getting into the sport or people who already are and want to have a little bit more understanding how their board works. If you want to repair it or if you just really want a better understanding of it. So I don't know where you want me to start, Sanjay, but just let me know.
So basically, I'm going to give you a quick overview. Samuel's a humble guy. He's actually double manufacturing and double mechanical engineering degrees from Oregon State. He's one of the smartest people I know who builds DIY skateboards. He is not a regular purchaser of skateboards in the e-skate market. He builds them himself because he has the fundamental knowledge needed to build e-skate. He doesn't believe in high-end boards because he can build a better one with his own hands. And today he's going to give us a description of the basics of e-skate. My background, I studied chemical engineering, physics, computer science. I've done some farming companies. So what does that make me? I'm just a stupid farmer. All right. But I like going fast. I like skateboards. I like e-bikes. I like people reducing their carbon emissions by using personal electric vehicles rather than combustion driven vehicles. And that's what kind of motivates us to get more people into this market. So the basics of e-skate are three things: battery, motor, and ESC. And we're going to start from the beginning of propulsion, which is what are the motors and what do the motors do? Why are they important?
Yeah, so obviously when you're looking at a way to create some kind of personal transportation, you want something that's lightweight. You want something that can provide a lot of power and something that's efficient and quiet. And so you've probably seen people running around on like scooters, like gas scooters and stuff. But there's limitations to what you can do where you can take stuff like that. And so part of the reason that I got into e-skate was because these electric propulsion systems are, for the amount of power that they can produce, they're very lightweight. So you have a electric motor about the size of a can of soda or something, even smaller than that, can produce 3 or 4 horsepower, whereas an internal combustion engine of that size would weigh significantly more. I mean, it's several magnitudes more weight, and they're louder and they're less efficient. And so the heart of all of these propulsion systems is, like you said, an electric motor. And typically what you're looking at is a brushless DC motor. And so not getting into too much detail, but they typically can range on electric longboards from 250 watts per motor up to 3,000 watts per motor, depending on how big they are, the geometry of the motor, where it is. There's direct drive versus belt drive and gear drive. And so just to kind of quickly break that down, a lot of the boards that I build are belt drive. So you have a motor that's connected to a belt that connects to your wheel. And if you've seen things like Boosted Board, which was an older company, all of their stuff was belt drive. And so that's a really easy way to connect your motor to your wheels. But like you said, the heart of that is your brushless DC motor that runs off just electricity from a battery. And so if you want me to move into that, I can talk a bit about the batteries.
So yeah, you talked about the motors and you talked about the batteries, but the things that puts them together is the ESC, which is programmable, which is different from board to board. And people don't know so much about what goes on in the ESC because it's kind of the black box for most boards. But what goes on there?
Yeah, exactly. So you obviously need a way to convert power from a battery where it's stored to the motor. And so these brushless motors, they work on a principle of it's called the commutated AC. So basically, you take a battery, and this ESC turns the electricity, which is DC, into it's kind of like a pseudo AC, which is what you would plug into your wall for. And so you might see, if you look up brushless motor, you might see that they have 3 wires. So this ESC basically just pulls battery power and converts it into 3-phase, so 3 wires, and that goes to the motor. But the cool thing about the ESC is that it allows you to take power from the battery and very smoothly transfer it to the motor. And so Obviously, when you're riding boards like these, it would be really bad if the motor just was on or off, right? If it was full power or no power at all, because if you're going slow and you go full power, you might crash or something. And so these ESCs, which is electronic speed controller, allow you to vary the speed of the motor smoothly. So if you have a controller, which typically you'll see people have little wireless controllers in your hand, it allows you to use like a thumb dial or like a trigger kind of to control the amount of power that you send to the motor and thus to your wheels. And so that's what the ESC does, is it kind of just smoothly transfers that power to your motor in a way that allows you to quickly accelerate, but in a controlled manner. And also conveniently, it allows you to brake using the motor. So like to bring back my comparison to stuff like scooters, you have to have mechanical brakes to be able to slow down, because that an internal combustion engine can't brake for you. And so the electric motor allows you to pull energy from the motor and put it back into the battery. And in doing that, you slow yourself down. So that's another reason where the efficiency comes into play, is through that ESC, where you can pull energy that you put back into the board to go fast. You can use it to slow down, which is really cool. So yeah.
When I know that most electric boards, they have regenerative braking. How is that, affiliated with the ESC?
Yeah. So basically, the motor, when you're traveling, let's just say, I'm just going to use, for instance, forward and backwards. So when you're traveling forwards, you're sending power from the battery through those wires, let's just say in a clockwise way. And I'll just use clockwise and counterclockwise just to kind of simplify the process. But you're basically, when you're going forward and you're accelerating, you're sending power clockwise through a motor, and it turns the motor in one way. And since motors operate on magnetic principles, you get a induced magnetic field that wants to pull the motor clockwise. And so when you want to slow down, or let's just say you're idling, let's say you have no induced magnetic field. So it's not slowing you down and it's not speeding you up. It's just, you're just coasting. But when you want to slow down, you want to reverse the direction of that magnetic field to slow down the motor. And so to kind of, what it basically does is put an induced torque on the motor to reduce your speed. So it pulls that torque from the wheel, which it's connected to. And from the wheel, it's then connected to the ground and you feel that slowing it down. So it's basically reversing the direction of current going through that motor and sending it back to the battery. And the battery obviously is where you store it. And so that's the regenerative aspect. Regenerative braking is you get to regenerate some of that power that you put into the ground by pulling it back through the motor. So.
That's awesome. Thank you for the explanation. Before we go into the next topic, which is batteries, I want to put in a quick warning here, and maybe you can discuss the warning in detail, but the warning is never ride downhill on 100% battery. Never ride downhill on 100% battery. Never ride downhill on 100% battery for a number of reasons, but Sam is going to tell you a little bit more about that.
Yeah, absolutely. So like I said with that regenerative braking thing, you can almost do this in an analysis with the internal combustion engine, but I'll put that off for a little bit later. What he means is as you go down a hill and you regeneratively brake, let's say you have to slow down because you've sped up too much, you're uncomfortable with how fast you're going and you want to brake. Because you don't have mechanical brakes, that energy has to go somewhere that you've put into the ground, or that, going down a hill, transferring your potential energy to kinetic energy. Where that energy goes is to your motor, and then to your ESC, and then to your battery. So if you're at 100%, your battery is already charged fully, as much as it can be. So it shouldn't be able to be putting more energy back into it. So when your battery's at 100% and you regeneratively brake going downhill for pretty much any extended duration, you're overcharging a battery pack. You're putting too much energy into it because that energy has to go somewhere if you're braking. So you can cause damage to your motor, you can cause damage to your ESC, and most commonly you cause damage to your batteries. And people that do DIY builds for their first time often experience this, where they've charged up their battery for the first time and they go out and they ride around. The first thing they do is find a hill or find somewhere where they have to slow down quickly, and they overcharge the battery. And sometimes it's just your battery, but if you're really unlucky, it can damage the ESC, and the ESC will you know, sometimes just shut off while you're driving, and in some cases that means the motor will stop, or it just, you won't have control anymore. And so that's something to keep in mind. The analogy I would use when talking about internal combustion engine is, if let's say you're going down a really steep hill, you're into gear, and it's going to rev the motor really, really high, trying to slow you down. But if it can't slow you down, you're eventually going to destroy your engine. And you might have heard, like, semi trucks that haul stuff, they have a thing called jake braking, which is where they use the engine to brake. It makes a lot of noise, and there's a lot of components that allow them to do that, but it doesn't work in an electric field, in the e-board kind of field. So it's definitely something to keep in mind if you're a first-time rider.
For sure, even experienced riders, 100%
Yeah.
downhill, it's
Yeah.
going to lead to bad problems, so don't do it.
Mhm.
So we've covered the motors, which is your main you're directly to your wheels, which directs to the ground, which is what gives you propulsion. We've talked about the ESC, which is what takes the power from the battery, applies it to your motors in a smooth, continuous manner in order to get you to the speed you want to be going comfortably. And the last thing we're going to cover in this video, which is the main Bojanga, whatever you want to call it, is the battery, because the battery is the source and sink of the power in your system, and it's your battery. Without that,
Exactly.
you don't have any fuel. So let's cover that. What do you think?
Yeah, yeah, for sure. So you're going to see a lot of different battery types, especially when you're looking at DIY versus pre-built. The main thing is, the battery is your fuel tank for your electric longboard, or really any electric, electric car, electric bike. It's the equivalent of a fuel tank in a car. And so it's used to store electrical energy that can then be transferred to your motor or motors and used to propel you forward. So just for a little bit of background, the main thing you're going to see are batteries made out of lithium lithium. There's lithium ion, there's lithium polymer, there's life, which is another type of battery chemistry. Teslas and stuff, they're primarily made out of that life technology. There's a lot of different chemistries. Most of it hasn't trickled down into electric longboards or other personal electric vehicles too much, simply because there are some dangerous chemistries, and that's something to take a look at if you're building your own electric longboard, is to make sure that whatever you choose is safe for where you're going to be using it. There's people that do DIY electric mountain boards, which allows them to go off-road and stuff, and they typically have higher current requirements, so they use lithium polymer batteries. The trade-off of that is that lithium polymer is generally more dangerous. Whenever you see videos of lithium batteries exploding or catching on fire, it's typically lithium polymer. And so that's something to take a look at if you're building your own, or if you're buying it. There are some boards that use lithium polymer packs because they're very thin, and so they have the highest energy density of all of the lithium batteries. Lithium ion some of them have higher density. It really depends on the manufacturer, but typically they're the highest, but they're the most dangerous. So if you're looking for details, make sure to look at that. But just for instance, most of the things like the Hamiltonian stuff, they use lithium ion, which are they look like really big AA batteries basically, and they're cylindrical, and they're cased, and they're a lot safer. And so if you overcharge them, for instance, like if you were in that situation where you were 100% charged and going down a hill, typically the battery isn't going to catch on fire and explode. It might damage it. Some of the cells are designed to vent, so they have electrolyte in them, and they'll vent if they overcharge, and that just prevents them from expanding too much and capturing a lot of heat and combusting or anything like that. So lithium ion generally is a lot safer, and that's why they're used a lot more in electric longboards. Another thing about them is that they're conveniently shaped, so they're cylinders, and they're very easy to design battery trays for and stuff. And it allows boards to flex a little bit more because you have individual cells, and that's something that you'll see if you're designing your own longboard, to consider that you don't want your board to be a solid brick. You want it to flex a little bit, or when you carve, you want it to have a little bit of give. And so that's something that's really nice with lithium ion, is it allows you to do that. But in terms of the technical details, typically with ESK8, you're going to see quite a wide range of voltages, all the way from 6S to 12S, and that means 6 series. And so you have one lithium cell is 4.2 volts, 2S would be 2 lithium cells at 8.4, and it goes up and up and up. Like I said, all the way to 12S, and sometimes over, typically not too much over, because then you get into really high voltages and they're harder to manage and charge and whatnot. But you're also going to see wide ranges of capacity, so how much energy they can actually store, anywhere from around 100 watt hours all the way up to over 300 watt hours. There's a bit of detail to take a look at if you're planning on transporting them, because if you get really high energy, you can't bring them on planes without lots of licenses and stuff. And I think the Hamiltonian is just underneath that, which allows them to be traveled on planes, which is nice. And that's something to keep a lookout if you're buying an electric longboard, is you want to be able to, if you want to transport it, you have to make sure whatever board you buy, you can. And a lot of times they don't tell you, because if they're over that threshold, it's a bad thing. And so, being right at that threshold is really good, because it allows you to transport it, but also have as much power as possible. So that's something to consider. Depending on, like I said, depending on the chemistry, they're going to be able to support different power outputs. And the cells that the Hamiltonian uses are really high quality. They're 2170s, which is a more recent evolution of lithium ion cells. They're what Tesla has been using for about the last 5 years, but a lot of the electric longboard manufacturers have not caught up to that. They've been using 18650s or lithium polymer, and that technology is on its way out, in my mind. I think that the future is the 2170 cell, or similar 21 diameter cells are definitely going to be the future for personal electric transportation. So is there anything else battery-wise you wanted to touch on?
No, I think that's awesome. I think that maybe some of the only things we may want to discuss is some batteries are 35E, some batteries are 50E, some are P42A.
Yes.
What do these things mean to the layman?
Yeah, exactly. So I'm going to go to a website and just for reference, pull a couple different cells. There's a store or a website called 18650batterystore.com, and they have a lot of these different manufacturers. There's lots of manufacturers, and there's lots of cell formats. So if you go here, they sell a lot of different stuff, and it gives you an idea of the different kind of batteries that people might be able to use. And so just going to their 21700 series batteries, Samsung is a big manufacturer. That 50E you said is the model of that cell. So 50E 21700, this has 5,000 milliamp hour capacity with 10 amp discharge continuous capacity. So basically, a single one of those cells can store 5,000 milliamp hours and can discharge continuously 10 amps. And at least at a certain temperature threshold. You can go above that for certain periods of time for acceleration and stuff. And obviously, manufacturers that use these things are going to be able to account for that. So that's something to consider. But it's really important you take a look at whatever longboard you're buying. If they don't list the cell type, it's something to question. There's reasons they won't, list it. If they're not using high quality cells, the performance you're gonna get out of your board is just not gonna be the same. You can buy, a lot cheaper cells, and you pay for it. You're not gonna get high capacity, so it's not gonna have a lot of energy storage, and you're not gonna be able to get a lot of current out of it, which means you're going to get really slow acceleration, or your acceleration is going to be ramped in a way that makes you feel like you're riding something slow. And so if you're buying an electric longboard and you're paying several $100s to several thousand, you want to make sure you're getting your money's worth. And chances are, if the manufacturer doesn't list what cell they're using, it's just not, they're probably using a cheaper cell. And so this 50E, for instance, this is a more recent offering from Samsung. And like I said, it's the cell format is, I think the future is 2170 for small electric transportation. But the 5,000 milliamp hour, for instance, is incredible for a battery that's, this tall. It's about that tall on a can of soda. And, it's barely double what a AA is. So it's, really, really a lot of energy in that cell. And Samsung is one of the best, if not the best, battery manufacturers for lithium ion. And so that's something else to consider. is the manufacturer that makes the cells, because there's, you know, the Sony, Panasonic, there's a lot of these smaller brands from Chinese manufacturers that aren't listed on this website, that, you know, it's tough to backtrack the performance of the cell. So that's something definitely to consider. And obviously, you know, if you want to really dig into it, you can take a look at the voltage curves for these batteries. So basically, as the cell discharges, how much voltage it's supplying on really cheap cells, as the, you know, as you're 50% of the way through the battery, it's gonna, the voltage it can supply is, you know, much less. Like, you know, you lose 25% of it in even just half, you know, half of the life of the battery. And a really high quality cell is going to hold that voltage really high the longer you discharge it, and that allows you to even, you know,
Keep going
halfway.
fast.
Exactly, it allows you to go fast. The voltage is a direct transfer to the speed that you can go. And so, you know, two boards that have 12S batteries, for instance, if they don't have the same cell, they're going to have different performance 3/4 of the way through your ride. And so the Hamiltonian, for instance, these batteries, these 50E cells, have an incredible voltage discharge curve. And so it allows you to, you know, at the end of your ride, you're still going to have a lot of the performance that you had when you first started. It's not going to feel as sluggish as some other boards will as you know, near the end of your ride. And it allows you to keep the performance as long as possible, which is, you know, a really good feature that is really important to know what kind of cell you have. So yeah. Thank you for bringing that up. The cells are very important to note. So
it's good to consider. So I have one last question. Somebody asked me this. What is P42A? It's a type of cell.
P42A. Let me take a look.
This is a misnomer. This is probably for the extras.
Yeah. It looks like Molicel P42A. So wow. Okay. So I see what this is. This is a really high discharge cell. So 4200 P42 is 4200 milliamp hours. So that's in the name. And then it can put out 45 amp.
Oh, wow.
45 amp continuous. Yeah. So now it's from a company called Molicel. I don't know if I've heard of these guys. But these are, let's see. So they've got, yeah, they're quite expensive. They're probably one of the most expensive cells you can get today. So they do have a nice voltage curve here. It looks all right. It drops a little bit more than you would expect, which is a trade-off. You know, you have a really high discharge amount, you're going to end up losing a little bit of that voltage. But yeah, these look like pretty nice cells. This is Molicel I'm not familiar with, and so something to just consider is, you know, you'll see a lot of these companies touting really high performance cells, and you know, it's possible, and you know, it may, Molicel may become a really big manufacturer, or maybe I'm just, you know, ignorant to what this company is. But you want to do a lot of research in whatever cells you purchase, or whatever cells your board has in it, because there are some companies that have really short lifespans on their cells, but they have really high performance. And so something that Booster Board ran into with some of their long range cells or long range battery packs that they had on their first generation before they brought out the boosted stealth, which is the black board that you see. They had these long range battery packs, and the cells that they used in them immediately were good, but a lot of them had wiring issues, but a lot of them also had life issues. So they only got, you know, a couple hundred life charges out of them before they lost a significant chunk of their capacity. And that's because the cells were pushed to their limits all the time. So, you know, the discharge curves of them very quickly started to fall off, and you get, you know, really bad performance at the end of the battery life. And that's something to consider, is if you don't know what kind of cells they are, and if they're not from a proven manufacturer, like Samsung, for instance, or Panasonic or Sony, you pay what you get what you pay for. And so the research is definitely important to make sure that whatever you're buying is going to last you a long time. And so yeah, but Molicel, in terms of the specs of this one, it looks very impressive. It would really come down to you know, the kind of you know, reputation Molicel has, and also long-term testing of a cell. And that's something that that really all you have to do is wait. You have to wait and see if it's something that people like using, if people are having issues with it, or if, you know, it's a winner, basically.
Yeah.
Yeah,
Thank you, Sam. I'm just gonna bring up my screen here for a second.
absolutely.
So we've covered the motors, whether they're belt drive or direct drive. They're
Mhm.
generally censored BLDC motors, and
Yep.
covered the VESC or ESC, which is
Uh-huh.
where power transforms into the wave, the electrical wave that
Yep.
powers the motor. And we talked about the battery and what kind of
Right.
batteries there are, 12S versus NP, parallel,
Mhm.
what goes on in there, whether it's 50, 35E, P42A, just different kinds of batteries and what goes on there. Later
Mhm.
on in our video series, we're going to cover the deck enclosure, the whole DIY process, and the physics of ESK8.
Yeah.
So stay tuned, everybody. Again, this is RE8, Samuel Wiewel, Sanjay here. Like and share whatever you want to do. If you don't, that's cool. Enjoy the knowledge. We're glad you were listening, and we appreciate your time, whatever time of day you're watching. We just hope that you ride safe, build safe, and cruise and enjoy. Have a good time. This is all
Yeah.
about cruising and having a good time.
Exactly.
Cool. Thank you.